Okay? Which, in my classroom, I have the circle graph on one of my boards. I think hers is on her smart board, so I'm gonna have to kind of draw one and go with it from there. But, if you'll look at your graphs, I went ahead, they go by increments of 15 degrees. So this first one is 0, then it's 15, 30, 45, 60, 75, 90. Does everybody see what I'm saying?
Is that the big marks or the little marks?
The lines.
So it goes by 15.
Goes by 15 degrees all the way around that circle. So here's a big version of it. This is 0. The next one is 15. I guess I should go ahead and extend it. Next one would be 30. Better try to make sure I get all the way around. Next one would be 45, which should be halfway in the middle. Next one would be 60. And the next one would be, and mine don't look evenly, because I'm just doing it by guess. Yours are all evenly 15 degrees all the way around. Do you guys see that? Then the next one up here is 90. This would be 180. And then the next one over here would be 105. Yep. Does everybody follow me there?
Yeah.
Has everybody got what the idea of it is?
Yeah.
Now, all these circles around here are called the radiuses. And mine, again, aren't going to look as pretty as yours. Because my circles aren't nice circles. They're just circles.
So the circles are called the radii?
They're the radius. We're calling them radius. Now, a polar coordinate is always written in polar form, which we're going to learn how to change it to rectangular form too, but not right yet. We're just going to learn how to graph polar coordinates. To graph polar coordinates, it's the r comma theta. Theta stands for the angle, and it needs to be written in degrees. So if it's in rads, here's a reminder. How do you change from rads to degrees? You multiply by 180 over pi. You want it between 0 and 360 because our graph is between 0 and 360. So what do you have to do in order to make it between 0 and 360? Like if I have 720 degrees, I would subtract 360 until I get there.
Yeah.
If it's a negative 400, I would add 360 till I get a positive. So it's either add or subtract 360 till you get to the right range. Okay? The r, you're just going to pay attention to whatever the r is.
Where's the r at?
The r is going to be the first one in your ordered pair. So it's always r comma theta. And theta represents the degree, r stands for your radius. So the first thing I want to look at is graphing 16 through 26. How do we graph these? And on these we're just doing the even here. And this we're doing all of them. Now this group, I'm going to go over them after we've done that, because it's going to take me a few drawings to get you on this one. So graphing equations, we're going to be graphing an r equals some constant, and we're going to be graphing a theta equals some constant. And again, this one you want it in degrees between 0 and 360. Does everybody follow me there? Okay, now, what I want to do is erase, you got that already written down, right? And we're ready for what we're going to be doing on 16 through 26. So let's say I have A is 330 degrees. So this one's an easy one because it's already what it needs to be. It's in degrees. So where is 30 degrees located? I chose that one because it's easy because I've already got mine. Here's 30 degrees and I want to go out 3 radiuses. So that would be point A. 3 means I go out 3 radiuses, and 30 degrees has to be on the 30-degree line. Now you've got a choice. Since I did give you graph paper, you can do them all on a separate graph, or you can put them all on the same if you want to. Just label them. Yes?
Does it matter where we start the 0 degree at?
Yeah, it always starts at the same location, where 0 is. Okay, what if I have 4 and pi over 4, 5 pi over 4. What would I need to do first in order to graph that? Convert it. So I have 5 pi over 4 times 180 over pi. The pi's cancel. 4 goes into 180. 45.
Do we only have to like write Like say it's 3:30, can we just go like 0 degrees, 15 degrees, 30 degrees, and that's okay, or do you want us to go through the whole circle?
You don't have to do the whole circle every time. You just have to get me there.
Okay,
You understand? You can count yourself mentally and not write it down.
okay.
Okay, so this one's for 225. So where's 225? That would be third quadrant, somewhere in the middle. Mine's not right on the middle because I didn't do in units. So it would be here for me, and I want 4 radiuses. So 1, 2, 3, 4, and that's my point B. Now yours should look a lot prettier because you've got everything's in correct units. Okay, don't worry about the negative yet. First thing you gotta find is the degrees. So where's 330 degrees? Okay, so I've gone around here, here's 180, down here's 270. So there's 330, well, I'll say 3, added 15, so it'd be 285, 300. This is not as good as yours, 330, 345. And the next one would be 360, because I'd be back here at 0. You guys agree that back there at 0 is going to be 360? So if I wanted to graph a negative 2, 330, here's 330. Normally, 2 radiuses would be out 2. But you'd go the opposite direction, just like you would if I graph on the number line. Here's 2 and here's a negative 2. So to graph a negative 2, don't I go the opposite direction? It's the same principle. So here, instead of going this 2, I go back 2. So that would be my point C. Let's do another negative.
Okay, can you explain that again?
Mhm.
'Cause I-
330, you found 330.
Yes.
Just do the
Okay,
opposite.
instead of going towards 2, you go away, because the negative goes the opposite direction. So I count back 2 to get where it's at.
So it's at 150.
Yeah, I would think that would be right. Let's do another one. This time I want a negative 3 of 15 degrees. That one's a quick one. So where's 15 degrees? Here's 15, right? Instead of going towards 3, towards the 15, I go back. So that would be here. Instead of going 3 to the right, you go 3 to the left.
Right.
Because it's just like the number line. Positive are to the right, negatives to the left. Okay, we good there? Now, so that would really end up at being at what, 195?
Yeah.
I think so.
So everybody agree there? Which you can check it, because they always add up. That's 15, that's 195, the difference is 180. Should be 180, because it should make a straight line. Okay, let's do another one with rads. Let's go 2 and negative 3 pi over 5. Then we're going to have to do one that's larger than our range. We haven't done one of those. What do I need to do first?
Over y.
So 3 pi over 5 times 180 over 5.
Cancel
The 5's cancel. 5 goes in 180, what, 36?
Yeah.
So that's
36 times 30.
108.
Yep.
But that's negative. Anytime you got a negative angle, what do you do to make it positive?
And 108 isn't.
Add 360.
Okay.
So what's 360 minus 108? 252? So I want to graph 2 and 252. So now 252 doesn't land directly on a 19 or 15 degree thing. Here's 270. What would be this next one? 255? And the next one would have been a 240.
Yeah.
So 252 is going to be somewhere in between. So you just estimate it. And I'm going out 2 radiuses. 1, 2. So that would be E.
And that's it for that one.
Do one that's larger. Let's go with 1 and 1200 degrees.
Would you just like subtract 360 by however many?
Until you get to a positive number. So what's 1200 subtract 360? So subtract 360 again. So subtract 360 again.
Subtracting 80 from.
I think you gotta subtract it 3 times, I think.
120?
Yeah, I think 120 is gonna be it. Anybody else get 120?
Yes.
So 120 is somewhere,
Yep.
there's 105. So 120 would be here. And I'd go out 1 radius. And that would be F. Okay, I think we've done every scenario you could have. We've done regular degrees of positive numbers, we've done where we had it in rads, we've done where we had a rad that was negative where we had to add 360, and we did one that was over 360 and we had to subtract 360 until we got there. Okay, you guys okay on graphing the polar forms, or color theta?
I believe so.
Okay, good, because this
I have-
ugly thing I wanna get rid of.
When we're, wait, when we're
Question,
going
Mason?
back, when we're going to the radius, is it like 1 from the middle or?
This is 0, 0, that point, just like normal,
Right.
that's the origin.
So,
So this would be run radiuses, would be 1 unit out,
okay.
just like normal, count 1.
Yep.
Okay, now we're ready for the last section.
Sweet.
Now this one you could do on the graphs if you want to, but you can also hand draw these because they aren't bad. How would I graph r equals 3?
Just draw the third circle.
1, 2, 3. So all I need is the third circle. 1, 2, and you really don't have to draw these 2 circles in between. You just need to let me know that the radius is 3. I just did that for emphasis. So you go out 3 units and make sure it's 3 north, south, east, and west.
What did you say these were? Not the
Equations.
Equations.
So you can either have the r equal equation or the theta equal equations. What if I have r equals the square root of 2? What's the square root of 2?
It's like 1.2 something.
1.4 something.
Oh, yeah.
So in between 1 and 2, I'd go 1.4 somewhere, north, south, east, and west. And then I draw my circle. What if I have r equals, I'm going to do a tricky one here in a minute. But right now it's just going to be normal. Whereas r equals 5.
Just draw 5 circles.
Go 5, 1, 2, 3, 4, 5.
Oh, dang it.
Mine doesn't look so pretty, but it's, you see that I see that I have 5 north, south, east, and west.
And if it's negative, it's exactly the same.
It's exactly the same. That is what my next trick was. What if I want the radius of -5?
Then you draw a -5, and it's just 5.
And it would be to the left, to the right, but it'd be north, south, east, and west. Likewise, it's just -5. When we think about it, it'd be in that angle.
Kind of like absolute value.
Uh-huh.
Okay.
Okay, is everybody okay with r equals? What if I say r equals -1? What would I do? Go up 1, north, south, east, and west? And that would be where it's always a -1. Okay, now, thetas. I want it in degrees. I want it between 0 and 360. So where is 120 degrees going to occur? Now, you guys can use your polar graphs if you want to, but I'm not going to since mine are, this is 0, 90, 180, 270, 360, right? So where's 120?
In between 90 and 180.
Okay, so it would be this, but it would be a straight line because we could be positive this way but negative this way. Do you guys follow what I'm saying?
Hold on.
120 is somewhere between 90 and 180.
Right.
So this is it, but you have to extend the line all the way through the origin
Okay.
because that would be the positive side where this would be the negative, right?
Okay,
Because you
so
go,
it's just it?
that's it.
Okay.
What if I have theta equals 60 degrees?
And between 0 and 90,
0 and 90.
go all the way through.
And go all the way through because it's a straight line. So 360 somewhere here. And that would be my,
That'd be too down.
okay, what if I give you theta equals negative 5 pi over 4?
Have to convert it to degrees.
So 180 over pi,
Negative 225.
add 360 so it's positive. So I get 135? So where's 135 located? So 135, somewhere in here? Okay, what if I give you theta equals,
What if it's a negative, would it just be the same?
add 360?
Oh, okay, yeah.
And just keep adding 360. What if I have theta equals 420? What would I do?
Subtract out 60.
Subtract 360.
That'd be 60, right?
It'll be 60, so where's 60?
60.
There we go. Because, and when you probably did this in the very first chapter of trig, didn't you graph 420 and you went around one time and then you ended up back there?
Yeah.
And they were coterminal because they landed at the same location? But we're just graphing the plane, so if I have a negative 500 degrees, what would I do on it?
You add 360.
So I'd add it twice, right?
So add 7
So it'd be 220?
Yeah.
So where's 220 located?
That'd be the third quadrant.
So somewhere here,
Yeah.
220 somewhere in there, between there?
Yeah.
And that's all you do. Okay, do you guys have questions on what you're doing on that page 558?
No.
Okay, so use your polar coordinate equations. You can either graph them all on the same but label them, or you can do them each on separate ones. And then you can graph the others using just your own t-graphs, or you can use the polar coordinate planes, whichever you prefer.
So can we just use the same idea?
Yes? And there's always going to be polar coordinate paper over here in the second bin in case you need it, if you need extra, if you make mistakes. Yeah, shut the video off, please. And then tomorrow, we are going to be graphing pictures.